Here is a Conquest branded dehumidifier. It's kind of a neat machine. We have a full indicator up top along with the unusual humidistat design. The humidistat sounds like it's working. If it still keeps an accurate humidity or not, I have no idea. I suspect that this driest setting is just a continuous run. This is more or less a Whirlpool product. I have one very similar to this, branded under Hampton Bay, the same kind of front cover, and it's a 25 pints, I believe. This one is a 40 by the old standard, and this has automatic defrost, automatic humidistat, which is of unknown condition, and automatic shut off. So other than having a 2-speed fan, this was about as top of the line as these came in terms of feature sets. The automatic defrost seems to be kind of difficult to come across. I suspect those models were significantly more expensive, not because there's a technical reason, but just because of some sales gimmick or whatever. This one I'm going to be giving to the letter H. He needs a dehumidifier and of course does not want to use a cheesy, potentially dangerous modern one. However, the area in which he's going to use it, he said the temperature can go as low as 68, which will most likely cause an icing problem. So it was imperative that we found one that has automatic defrost to take care of those issues. Really the only downfall to these older units is that they do not tend to handle well in lower humidity conditions. At least from my experience, a lot of them start to ice up around like 71 or 70 degrees, which is kind of dumb because basements where these are typically used are often cool. This one's in rough shape, needs a serious cleaning, very dusty. Definitely never really been cleaned or serviced at all. The coil on this one is a relatively high number of fins per inch, so I wonder if this one's going to run a little bit warmer than some of the other ones, like with the circular coil design and so forth, that have no fins. It'll be interesting to see how this one handles. There's the information tag. The Whirlpool Corporation. It's a model number BUDH4000Y50, 40 pints, has gas 500, 9.75 ounces. Conquest, whatever that is. The R500 is a very good refrigerant. It's very low pressure, even lower than 22. Actually, I think it's significantly lower than 22. Rust is not too bad. Pretty good on this side. There's a little bit of rust on this side, but really nothing to speak of. Certainly nothing out of the ordinary or to be concerned about. We have our humidistat down there, and then somewhere on the return line, I guess maybe on the other side, would be the defrost sensor. He is going to use this machine in continuous drain configuration, so I'm going to give him this bucket to use with it. This bucket is broken. It has kind of an unusual failure and a usual failure. The unusual failure is that it leaks out of that little hole up there. I've tried to seal it up multiple times and did not have any success. However, if you use it in continuous drain, it doesn't matter because the water level will never go past this and the hole is up there. So that leak becomes irrelevant. The other problem with this bucket is that one of the hooks is broken off. And the purpose of that hook is to hold it, is to suspend it from the front of the bucket, and then when it fills up, the weight of the water pushes in this switch here, which you can adjust the tension with this. This was not a very good system. It kind of worked for the most part, but it was pretty flawed. The float switch is much better, because sometimes when this would initially turn the compressor off, because it's reciprocating, the whole thing shakes a little bit, and then this would, you know, it would go like that, which is not good. And it works fine. Again, if you're going to use continuous drain, just take a 2x4, put this under the back to keep it steady, attach your hose, and both of those failures become irrelevant. So it's a good use case for this bucket, which is otherwise pretty much garbage. That's that. We'll clean all this up, try to make this look a little more presentable. This was a free in the Facebook Marketplace, and it's not hard to come across these for free, because to the majority of the population, these are considered absolutely inefficient garbage. And while they are inefficient compared to ones that use PSC apparatuses, I don't know why a lot of these did not use a PSC compressor and fan motor. Could have cut the power draw easily in a third or more if PSC motors were used, but they weren't. So it's all shaded pole or whatever the apparatus is. Somebody was saying in another video that it's not shaded pole, but I don't know. Maybe it's not, I'm not sure. But they are inefficient. However, the trade-off is safety. These machines are safe, they're reliable, they're excellent. You know, despite the inefficiency, these machines they're built to last, and they're built to proper spec. It's metal, it's built with quality components that are to decent spec. These are about as far from obsolete garbage as you can get. These are powerful, dependable, and safe pieces of American and Japanese engineering that even at this point in time, after they're already 30, 40 years old, have decades of service life left in them. The reason why you can get these for free so often is because most people want to just throw them out and replace it with some cheap piece of junk from the local hardware store, which is going to break in a couple years. And disposal of these things is not easy. And, well, it's not cheap. Most municipalities charge a pretty hefty amount to discard one of these things, like 20, 30, 40 hours, sometimes even more. And that's not money everybody has. I mean, even to me, that's a lot of money. Like, that's lunch for the week. And then some people physically can't pick one of these up and move it. So I don't know how that whole system is supposed to incentivize people to use recycling when it's so difficult, but that's a whole different conversation. So this one has oil ports in the fan. So every year, a couple drops of oil. The fan motor is a what is that brand? MagneTek? I gotta look at that myself. I can't see it through the camera. What the heck is that bundle? It is a MagneTek MagneTek Universal Electric Motor. It says oil. I can't see. We'll take it apart more later. 0.45 amps, 1550 RPM. But it's not a PSC fan motor. It's a basic shaded pole motor, and it's just not that efficient. But it's safe. I would never expect this to ever catch on fire. I would run this unattended, continuous, without a second thought. You know, all these wires are nice thick gauge wires, metal, 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 metal. Even if something did happen, it's contained in a metal box. This kind of looks like it might have been tampered with at some point, so we're going to have to we're gonna have to check that out and make sure that that was done correctly. I don't see, it looks like, yeah, we're gonna have to check that. It looks like somebody grabbed the common, and maybe that's how it's supposed to be. This tie wrap does match these, but this does not look factory to me. So as anything else, we'll check it, but that seems kind of weird. That's the humidistat down in there. I don't see where the, oh no, that must be the defrost sensor. That's why it's a thermostat. This is the humidistat up here. The, oh jeez, well, I wasn't ready for that, but okay, I guess we're running now. What I was trying to show is that that's probably the defrost temperature right down there. We saw that probe on the other side of the coil. Now something is rattling, something awful in here. And it's so out of balance, it feels like the fan motor's missing a blade or something. So that's all just, I don't know what's going on with that. Yeah, this is so rattly and loose. Alright, we'll fix all that. I don't know why it's so out of balance. Well, aside from the noise, it started up and runs perfectly. It's an Embraco compressor, which is a well-known brand, reputable, made in, it says made in Brazil, which, as we know from Carrier products, Brazil makes excellent HVAC equipment, top of the line. Kind of an unusual place to hear something made from, though. Gosh, this stupid fan is ridiculous. You can barely hear the compressor. It's a shame the daggone fan is so loud. Actually, the fan is not that loud in this machine if it wasn't for all this vibration. It's relatively quiet compared to some of the other ones that I've used. Now, the power information is 116 volts, 5.8 amps, which actually is not too bad. 513 watts, power factor 0.76, so it is not PSC style, which I just don't understand. There's some insulation on the bottom here, which also leads me to believe there's been some tampering at some point. See, all these, the return line is all insulated, so no water ever gets into this portion of the apparatus. That's all the, oh, I see what the problem is. I'm missing a bolt. That's half the problem. And here it is. Maybe we can quiet this down for the video. It won't stop the root of the problem, which is all this vibration, but maybe we can quiet it down. Okay, well that's already much better. That was an easy fix. It's still vibrating a lot, so actually it's not. It's not vibrating anywhere near as much as it was. I think this is within reason now. Huh. Is that all it was? Unreal. That's all it was, a stinking missing bolt. The fan blade still seems kind of out of balance to me, but it's not that bad of a thing. I would just leave it alone. Yeah, it's not shaking anywhere near as bad as it was. I can definitely feel it. It's not perfect, but I think we can live with it this way. This is reasonable now. Let's see what we got on the other side here. So we got nothing in terms of ice yet. Coil is cold. At the bottom it's cold. Almost all the way up. Take another minute or two to finish building the pressure. We got a little bit of ice forming on here, but that should go away. It's 77 degrees in here. If it ices up during this test, then something is wrong. It's starting to sweat. The humidity is only 37% down here, so it's not going to pull much moisture. But we should be able to see everything sweat top to bottom. This should melt off of there. That's actually kind of a weird spot for it to ice, because it starts from the bottom. The capillary tube's on the bottom, and the bottom rung is not iced, it's just wet. So that's kind of peculiar. I am so glad it was just a missing bolt. I thought there was something seriously wrong with that fan. It's running really nice now. Huh. Unreal. You never know what you're going to come across in this kind of stuff. Alright, that's the auto shut off, I think. Didn't really want that to happen, but I guess we can go ahead and check the light now. Now, see what just happened? That's what will happen when unplug this here. That's what sometimes happens with this apparatus, but it is what it is. He's not using the auto shut off, so it doesn't matter. It's not broken. That's the way it is. It's not the best design. Let me check this light here. Turn this off. We'll also need to check the plug after a while, make sure it don't heat up. It probably needs a new molded plug. Well, our light is not working, and maybe that's why this was tampered with. Again, it doesn't matter. He's not using the bucket for filling up. So we're probably not going to play with that. I'll ask him if it's a big deal, but he would never see the light come on anyways, because if it's being used with continuous drain, that's not a feature you're ever going to need. So I'm going to turn it back on, let it sit for a while. I got to do some other things here. Give it some time to operate, and then we'll come back and see what it's doing. It's not going to pull anywhere near enough moisture to fill up the bucket anytime soon because of how dry it is down here. Wow, it's running great now. All that noise is just that one bolt that came loose. Yep, it's building head pressure. I can hear it. I've had the machine running for 24 minutes. It's pulling 5.86 amps, 5.89 out of the 7.4 it's allowed, 531 watts, power factor 0.77. So that amperage is reasonable. It has started to pull water. Humidity down here, which is very low. Now there is ice on this one side. There's no ice on the other side. See, it's all the way to the top. And the whole coil does feel cold all the way through. So that's kind of weird to me. Now in the machine's defense, the coil's not getting a lot of airflow. So the temperature of the coil is going to be lower than it's supposed to be. So we do need to clean it out before we start making any assumptions about that. It's probably fine. It will likely go away after cleaning. The return line, I can feel it's cold. Even even through the insulation I can feel it's cold. So I think everything's fine with the charge. This is exceptionally hot. Maybe that's just how it is, I don't know. I'm not super familiar with our 500. Compressor temperature is reasonable. It's coming out warm, not unusually hot. But I think everything is fine here. So the next thing to do is to take this outside. We'll clean the coils off, and then once I've cleaned the coils, we'll let it run for an extended period of time and make sure that goes away and everything else seems fine. The ice disappeared within seconds of shutting it off, which is why I think that little airflow reduction there might be causing the problem. It's definitely worse on the right side than the left. The dust is for whatever reason, which is kind of weird. I don't really know what purpose this piece serves. There's no filter or any way to attach a filter, but there's that. Left in there. The 4 screws takes off the entire case. Well, actually, we gotta do something in the front here too. We need to remove. Oops. We need to remove this apparatus from here. Why is that not? Oh, it stays on there, so that's kind of cool. Whatever water's left, this is going to have to go on the table. What the heck is that? That came flying out of there. We're going to have to do something about this cord too. It's not broken, it's just frayed. It looks terrible. The molded plug did not heat up over that test, so maybe it's fine. Okay, we've got a data sheet here. This talks about how to adjust the auto shut-off apparatus. So this only goes down to 70. 80 is the asterisk because that's where the testing is performed. 60% is where the rating, 80 over 60%. That's the old standard. The new standard is 65% at 65 degrees, which actually makes more sense. This is wattage draw under these conditions 7.4 amps. So we're a little bit below that. in terms of temperature and way below that in terms of humidity. So you can see at 70 it's only pulling way less than it does at 90. This affects the temperature. So even this shows you it's really not meant to run much below 70. Here's our schematic. So we'll leave this out for the cleaning and put it back and we're done. What else is there that's noteworthy in here? Well, there's some rust on this stupid steel piece, which I wish was not, just wasn't designed that. I don't like that design, but that's the way it is. They're all like that. So we have some pieces of cardboard here up at the top, which is a little odd. We're going to cut those out for the cleaning because that's going to get ruined if it gets wet. There would have been weather stripping like material around here. That's all rotted off. That's what this stuff is in the bottom, which I can't even pick up to show. Probably should be replaced at some point because it'll the air from the coils, it needs this to draw through the air properly, so we might need to, I don't think I have any in hand, I'll have to check, but maybe the letter H can go back and add that later on, and not too difficult to take care of. The coils are pretty clean on the inside. It's really just the outside layer that's going to be dusty. And now this fan, I don't know what's up with this fan. I guess the blade is out of balance. The blades are very flimsy. You know what? I bet just the way it goes on is throwing it out of balance. I wouldn't be surprised if having the screw like that is what throws it out of balance. Because sometimes that's all the weight it takes when it's spinning very quick. The information tag says the heck? It says number 20 non-detergent oil, each tube. Doesn't say the increments though. Alright, well, let's take it outside and clean up these coils. Get this thing looking a little more presentable. Then we will check out this wiring here and see what's up with that, because that is kind of weird. One more thing we're going to do before the cleaning is I want to take this thermostat off of there. That's going to be for our defrost sensing temperature. I don't want that to get covered in the coil cleaner. It's rusted pretty bad. Those clips should have been made out of something else. We're going to have to do something different for that. That's terrible. We're not going to need a lot of coil cleaner because this is a small coil. We're not going to need much coil cleaner at all. This is going to come real clean quick. Look at that. Coil's in good shape. There's hardly anything here to clean. This sprayer definitely needs a new gasket. It's just not building the pressure that it should be. I think the rest I'm just going to pour down the evaporator or the condenser because I can't really get to it. Look at that water going right through the coil. Perfect. It's so important to rinse the living daylights out of these machines after using that cleaner. Because if that sits on there over time, it just wrecks the coil. Why is this pressure so poor? Oh, they're not in the hose. So for a few more minutes here and we'll be done with this. Alright, that's good for the coil cleanup. You can see right through the coils now. Perfectly clean. This will dry out here in the sun. Now I'll work on the cabinet and the case. We're going to use vehicle wash to clean this up. That was pretty easy. I'm using a very soft brush. This is like a rims brush, so it will not damage the surface of this. Alright, we're all set with the outdoor cleaning. Coil's in much better shape now. So let's oil the fan motor and then we'll let it run for a while and see what happens. Now that we can actually see the information's tag, it says the brand is MagneTek or MagneTek, however you're supposed to pronounce it. kind of a cool, clever name. Universal Electric Motor. It is model number JA2M349R pound. Impedance protected. 0.45 amps, 1550 RPM. 0.1. No, it's 0.01 horsepower. And no indication on how old it is though. This is probably a 90s product. Likely one of the last couple ones that would have had the wood grain cabinet still. So we got two oil ports on the top of the motor. We've got some 3-in-1 oil here. This is not the can that I usually use, is it? What the heck? I thought that I had a... Yeah, this is not the can that I usually use. What the heck? Did I run out and I just don't remember buying a new one? And this is pretty much full. Oh man. Huh. Well, it still says for fans. It also says for the lawnmowers, but I don't see what you would use this for on lawnmowers, and whatever the heck that is, I have no idea. It's like the end of a spatula. It's not indicative of how much or how often, so we'll just put a bunch of drops in. I'm sure it's probably never been oiled. Okay, now we'll move to the front bearing. Get in there. Why isn't it going down anymore? What is this for? It's clogged? Hello? That's peculiar. I mean, the bearings are in excellent condition. It does not seem like it's in need of any oil, but it really should have it. Why the heck the oil is not going down? That's really odd. Well, hopefully it'll go down as it runs. Alright, let's test it. I'm going to put a piece of wood over the top, which will kind of simulate the cover being on, and direct the airflow where it needs to go. Oh, before we do that, let's also check out this wiring here. It's a perfectly good connection. I don't see why it would be like this, but I don't see any reason to mess with that. I suppose we should probably take a look inside the compressor terminal box as well, since one of the wires does come out of there. Just make sure that it wasn't, make sure nothing was tampered with in there either. You just never know with this stuff when somebody's been tampering and doing stuff wrong. These are a little tricky to get off. There we go, it wasn't too bad. So here's our starting apparatus. And that's just coming off the common. That terminal looks factory to me. Overload at the bottom. Yeah, everything seems fine here. Nothing's rusted or corroded. I don't know what that terminal would have been for. That kind of looks like it would have been ground to me. But, I don't know. Well, everything's checked out in there, so we're just going to put this back on and leave that alone. No point in messing with stuff that's correct. Coming off the fan now, so I would not be surprised if we don't get any ice this time. The discharge is scalding hot, but nothing in the condenser is hot. So the condenser is working properly. This fan motor, the fan blade rather, could definitely use some balancing. It's pretty far out of whack. What might need to be done is perhaps you get a second hose clamp on there and stick it with the screw on the other side and see if that fixes it. I have a hunch that that might be what the problem is. The head pressure has not built up yet, it's only 5.5. It's climbing up. It should be climbing up any minute now. So this is more what I would expect in terms of the ice. I would expect a little bit of ice right where it comes out on the bottom when we first turn it on, and then as the head pressure builds up, this should melt off. It is cold all the way through. I've had it running for a while now. I want to say at least a half an hour. And the head pressure has come up and all the ice has melted. And you can see it's sweating all the way to the top. Coil feels cold. And it's sweating at the bottom right before it goes back to the compressor. Now, something odd I'm noticing here is that the very top of the coil on the back, a couple layers down, is not cold. It's cool, but it's not cold enough to sweat. And normally I would say that's not correct, but if you look at the rust line here, it's very clear that it's never been cold in that particular corner. So the way it's operating is the way it's always operated. So I think it's fine. It's working pretty good. You can see the drops of water forming inside the coil there and running down. It's working very well. It's only 41% humidity down here, and it's pulling a considerable amount of water for that humidity. Now this here is a cosmetics issue. I've checked the cord itself. It's in good condition. The insulation is not breaking. It's not flexed too much. As you can see, I'm holding it. It's not a safety hazard. It's just a cosmetics issue. I'm also noticing that the molded plug is not heating up, which is kind of surprising. So I'm going to leave both of these things alone. I'm going to leave the cord alone. Yeah, I mean, I really can't, it's not ambient temperature, but the amount of heat that's coming out of there, to me, is not a concern. You know, use your discretion on this one. If you feel like you should replace the cord, it's easy to do so. It's just 3 wires here spliced on a new cord. This you could probably reuse if you cut the bottom open here. If you cut down up to where the wire is, you might be able to peel this apart. It doesn't look like it's intrinsically part of the wire, but I'm not sure. So I'm just going to leave this alone. It's cosmetic down there, and this, to me, this is within an acceptable range of heat. I'd say everything checks out here. Okay, we're just about wrapped up with this. I got the stuff in from outside. It's all dried off now. It's not a thing of cosmetic beauty. The cover itself isn't too bad. There's some scuffs at the bottom. The case is really not the greatest. Chances are much of this could be cleaned up further. It's got a lot of these black marks on there. I'm not sure what that is. The top is kind of scratched up. It's got some paint droppings on there. Same thing on the other side. One of those black marks and various scuffs. I just don't have the time to go through all that and try to get it off. It could definitely come out better than it is. My objective here was just to get it into the condition of no mold and functional and ready to use, which it is. So the last thing we have to do to make the setup work is we got to come over to the bucket here and drill a hole in this. I got to go empty this out now. It's full. We need to very carefully drill through the hose connector there. I think I'll go with like a 1/4 inch hole. There's no reason to go with anything bigger. It's not going to be pouring water out that quick. I think a smaller bit is probably a safer option in terms of the risk of breaking anything. We'll go with this one. Okay, that was easy. And I suppose if you ever did want to use it as a bucket collection again, you could just put a hose cap on there. I should have drilled it lower because then it would drain out. There'd be less water sitting in there. Let's see if I can do it a little bit lower. There we go. So that's almost level with the bottom. So now hopefully very little water will actually accumulate and stay accumulated in the bucket. Alright, so that's that. Now we just need to reassemble, which won't take long because it's only a couple screws. So just some feature suggestions maybe over the winter. What I would do is open this back up, get 2 pieces of wettest stripping and stick it on these 2 areas there, and then maybe look into why the fan is so out of balance. There's nothing physically wrong with the blade, it's in reasonable clock and etc. So it might be a matter of putting some lead tape on some of the blades. I really think it might be that hose clamp that's throwing it off. Or what the heck? It actually looks like there might be some weights or something in there. Alright, now this is, we're gonna have to take a quick peek at this because the curiosity is gonna get the better of me. Something looks funny in here. We're going to be better off undoing these other bolts. Look how easily this fan comes off if you needed to change the motor. And the motor is probably a standard size as well. Look at that. Talk about serviceability. That is just fantastic. Wow. Excellent, excellent serviceability on this thing. So, yeah, why is that like that? I'm looking at what are these things? Is that metal? Those almost look like weights to me. I don't know. I don't know what that is. Wipe off some of the excess oil that spilled while the port was clogged. I don't know. I feel like that could be enough to throw it off balance. That screw and that extra metal there, because it don't take much. But then it seems like maybe this is throwing it off balance. I can't tell if that's metal or plastic, but there's definitely extra weight there. I don't know. And then the blades are numbered, so it's almost like there was kind of some balancing, some kind of balancing something that happened. I don't know. That's weird. Played it over the winter. I don't know. You'd be able to get that in balance. Just a matter of adding probably some lead tape on the back of one of the blades. But due to the time constraints, I can't play around with it. I can't believe how easily this is serviced. This is fantastic. This is equipment designed the way that it should be. This is how everything should be. Simple to service and replace parts that are known to wear out. And the fans in these are definitely known to wear out. Not so much because they're bad fans, but because nobody oiled them over the years. This one's in pretty good condition. It's a little surprising. Alright, so now we'll put the cover on. Oh, jeez. I didn't know that was in frame. This came out of it when I opened it up. I don't think that this has anything to do with it. I'll keep it, and if it turns out that it does, I'll send it to you. I don't think that it does. That's cool. Now, this is definitely weird, but I don't see anything dangerous about it. it will be important to make sure that this auto defrost probe stays up against the coil, and if we find that it doesn't work, we can adjust the thermostat, the cutoff point. I have no idea where it's set right now, and it's not cool enough to test it. Now this thing, I don't know what the purpose of this is because it doesn't hold a filter or anything, but this goes on here like this, and sometimes this will knock off the, yeah, see, it's knocking off the defrost probe. I wonder if I can move it up a little bit maybe. That might be okay like that. Now this way this will not be hitting that. So if it ices up and it doesn't seem like it's cutting off, you might just have to play with that a little bit, make sure it's up against there, or what the heck was that thing? Or adjust the temperature. But that's that. Might be beneficial to put a filter on the inside perhaps. And then this goes on here like this. You will have to watch out for that. The bucket, since the hook is messed up, tends to want to shut it off, you know, when it presses down. So if you just got a piece of wood, this is a 2x4, something slightly thinner would be better. Just put it up under there like this, it'll work perfectly. And then we'll attach a hose, and I'll pour some water in there to make sure that it's working. It doesn't work. I think there's not enough water in there yet. You know what? Duh. There's a dehumidifier sitting down here that's full of water. There it goes. That's draining very slowly. I mean, granted, the machine will never put out that much water. I don't know why it's not going faster than that. Doesn't seem like it's clogged. No, it's not. I can't offer any explanation as to why it's like that. It must be the hose. The hose itself is leaking now. I'm going to get a different hose because I want to make sure that this really doesn't leak. I don't want to produce something that doesn't work. That's kind of crummy. Oh, that's why it's leaking. It doesn't have a gasket in there. Now it would have gasket. Okay, now it is not leaking. Well, we'll go ahead and turn it on and let it start pulling water, and then we'll see how much it really pulls real time in terms of the way it drips. This thing is actually fairly quiet. The fan is much quieter than some of the other ones I have. I'll let this run for an hour or so, and I'll come back and we'll see it operating properly with the direct drain, and then that'll wrap up the video. About an hour and a quarter of operation, 6.18 amps, 574 of the watts with a power factor of 0.79, 6.17 is within reasonable spec. This is working. This is the rate it's dripping at 42% humidity, which is very low. Nothing's leaking. All seems copacetic.